Hi everyone, in this video we're going to record about the first thing, understand the Kadane algorithm. Kadane algorithm is Kadane algorithm first will check the problem statement, then we'll take one or two example, then we'll check it, solutions, and then at last we'll check the code. Okay. Now what the problem statement says? Problem statement says that if we want to know the maximum sum subarray subsequence, okay, so that time we use the Kadane algorithm. Means we want find the maximum sum subarray. Let's suppose this is the subarray which has sub element minus 1 0 2 minus 3. Okay, so we want to find the subarray which sum is maximum. So the subarray can be maximum sum is this one. Okay, we just want a maximum sum value. Okay, not subarray. Okay, now let's move to another point. So let's take one example. What we have given one array which has sub element. Okay, let's take first example. Let's suppose all the elements are positive 1 3 0 2 6. So what will the maximum, what will be subarray maximum sum? If the all elements are positive one, okay, it means the array itself will be a subarray with sum is maximum. Okay, so Kadane's algorithm is useful when we have a negative value in an array. Okay, so let's take one more example. Now what I have 1 0 minus 3 1 6 minus 8. Okay, maximum subarray subsequence we want to find now. Okay, now let's take one thing. To solve this problem, we will take two variables. First variable will be the maximum so far. What is the minimum of maximum so far? Maximum so far means if we process the any element. Let's suppose we are process the element 1. It means till before the processing 1, how many? Sorry, before the processing 1, what the maximum value so far till it we got it. We'll check that point. Keep the score of that point, and then maximum ending till it here. What is the maximum ending till it here? Current value. Okay. Now starting point we'll check it at a 0. Okay. Now what we'll going to do? So first we'll take the first element. Okay, now first element is 0. We add the first element to the maximum ending here. Okay, after adding the first element 0 to the maximum ending here, it will become 0, and that is less than or equal to maximum ending here, so we will not apply the maximum so far. Okay, now we add the minus 3. Okay, now when we add the minus 3, okay, it will become something minus 3 which is less than maximum so far, so we will not apply maximum so far. Okay, now we move this thing to the next step. Now what will happen? The maximum so far will be minus 2. Okay, now see, the maximum ending here is minus 2. The one point is here, the maximum ending here is minus 2 to the sum till this point. Okay, to this point till it here. Okay, and also what we check that this is less than the current element. So current element can be one solution as well. So maximum ending till it here will become 1. Since it is larger than the maximum so far, so we will apply the maximum so far by 1. Now we move the current iterator to the next point, the 6. To add the maximum ending here to the 6, it will become 7. Now the maximum ending here is a lot greater than maximum so far, so we will move next step. Now in the next step, what will check it? Check that maximum ending here is greater than the maximum so far. So we'll update the maximum so far by the maximum ending here. So it will become 7. Now we move to the next step. Next step is 8 minus 8. We'll add minus 8 to this variable. It will become minus 1, which is less than or equal to less than minus 7. So we'll not update the minus 7. So what will we get? We'll get maximum so far here. Okay. We'll get the maximum so far here, this one. So this one is our answer. We'll return maximum so far at the end. Okay, now we'll take one more example. Let's suppose we have given an array, okay, whose variable is -1, -2, and then -4. Okay, all elements are negative. When the all okay, so what we check maximum ending here and maximum so far. Okay, so maximum ending here we check the first point as something 0. Maximum so far, let's take it int max or int min. Okay, now we take in the -1. We add the -1 to the maximum ending here, which is -1. Now what we'll check it? We'll check that is the maximum ending here is greater than the current value. No. So again, now we'll check it. Is the maximum ending here is greater than the maximum so far? Yeah. So we'll update the maximum so far as a -1. We'll move our cursor to the next step, -2. What will check it? -2. We'll add a -2 in the maximum so far, so it will be -3. Okay. Now we'll check it. Check that the maximum ending here is greater than current value. Yeah, it is less than the current value, so we'll update the maximum ending here by the -2. We check that -2 is the maximum ending here is greater than -2 maximum so far. No, it is less than maximum so far, so we'll not update the maximum ending so far. Now we'll move our cursor to the next point. At the -4, we add a -4 to our current value. It will become -6. Is the -6, which is the greater than the maximum current value. No, it is not a maximum, so it is less. So now again we'll check the maximum ending here is greater than maximum so far. No, it is not maximum so far here, so there is no update. Let's suppose there is one variable, that is the 0 or any positive value. Okay, when we add the maximum ending here to this current maximum ending here, what will become the maximum ending here? It will become -6. Is this current value is less than the current? Is the maximum ending here is less than the current value? Yeah, it is a less than current value, so we'll update that is 0. Now we'll check it. That is the maximum ending here is the greater than maximum so far. Yeah, it is the greater than, so we'll update the maximum so far by the 0. So at last our answer will be this thing. This is our answer. 0. Okay. Now let's move to the code. Write the code. Has we'll add the code. Has include bits std c++.h using namespace std int cadence or maximum cadence int maximum sum subarray. Okay, maximum sum subarray. Okay, subarray. What we are given vector int b. We don't want to change it, so we'll make it a constant. Okay, now but we have taken two variables, int maximum so far. Maximum so far is equal to int maximum so far is equal to int min into maximum ending here equal to 0. Now for auto x current value, current element to be array. Okay, so maximum ending here, maximum ending here is equal to current element. Okay. Now if what is happens if the no, there was a point when the maximum ending here, if maximum ending here is maximum ending here is less than current element. Okay. Current element, so we'll update the maximum ending here, maximum end here by the current element. Okay. Now check it, if maximum ending here is greater than maximum so far, so what we'll do maximum so far equals to maximum ending here. Okay, so now this one, so return maximum so far. Okay, let's write a driver class, driver functions, driver function. Okay, now driver functions, let's suppose int main vector array, which is element 1, 3, minus 2. Okay, and we want to see out maximum sum sub array. Pass that array to the header. Okay, let's write some more point, some interactive point here. Maximum sum of maximum sum. Okay, now I execute this program. So, maximum sum is 6. Okay, let's do some trial. Trial is there. What we have given? We have given this value 1, 2, 3 minus 2. Okay, what we have given? We have given 1, 2, 3 and minus 2. Okay, so we take the minus 6. This one is the maximum so far. Okay.